Hello everyone, welcome back. Today I'm going to talk about characteristic strength, characteristic load, and few other topics of RCC. The first one is characteristic strength. It is defined as the strength of concrete below which is not more than 5% of the test results are expected to fail. For example, if we consider 100 cubes of M20 concrete block, in that if we test all the 100 cubes, in that only 5 cubes are expected to fail. I will repeat once again. For example, if we consider 100 cubes of M20 concrete blocks, in that if we test all the 100 cubes, in that only 5 cubes are expected to fail. But all other 95 cubes are expected to reach the expected value of M20 concrete. So in graph we can see that the x-axis represents strength of concrete, like 10 MPa, that is 10 megapascal, M20, M30, M40, like that we can consider anything. In that the first initial will come from the left side, that is 0%, and right side it will be 100%, but we are focused only about this 5%. So 5% should be failure, that is why we have drawn this 5%, and at the mid the peak value is average strength we are getting in the test result, that we call as a mean value. Mean value should be in that span. Mean value is the actual strength of 1.664 s, which comes in mixed design, that is a target strength, and also this target strength will be more than the actual strength. For example, if we take the target strength as M20, actual strength is M20, then target strength will be 23, 24, like that. And also if I want to explain it more, I can say like this also. In graph I have said x-axis is a compressive strength of concrete, where here whatever 5% has we have made it, it is for a fail, or these are all the defective, and 95% is with no defective pieces. For that we have a formula as Fk is equal to Fm minus 1.64 s, where Fm is nothing but mean strength. Okay, the mean strength, it starts from the 25 up to 40 is Fm. Okay, Fm means the mean strength, it is between 25 to 40. If this Fm, if we substitute it here in this formula, we will get 5%, that is nothing but FCK value. Okay, this is about the characteristic strength. Next is characteristic load. It is a maximum load on structure which has 95% probability of not being exceeded during life of the structure. Characteristic load are which that have 95% probability of not being exceeded during service life of concrete, or maximum load that the concrete should take during its life. I will take up with one example. If we consider a beam which is designed for a design load of 25 kilonewton per meter square. Beam is designed for a design load of 25 kilonewton per meter square. Then throughout the lifespan of beam, only 95% of 25 kilonewton per meter square load should take, okay, or it should take only that much, only 95%. That load we call it as a characteristic load. And as I said, it will take only 95% throughout its lifespan, but remaining 5% should it will not allow the structure to take. And at mid we can see a mean value, that is 5%. We have hatched it here. Okay, the graph is not clear, but we have hatched it. So if we for example, if we are designing for a, one more example is, if we are designing for a load of 50 kilonewton per meter for beam, if we consider a lifespan of the structure is 100 years, so throughout its 100 years load will reach only up to 95% of the of 50 kilonewton per meter. That is nothing but, if we calculate, the value will be 47.5 kilonewton per meter. It will not reach up to the complete 50 kilonewton per meter throughout its life. And about this graph, the x-axis is a load, the midpoint is mean load, left part of midpoint is LM, that is this portion, left part, and the remaining is 1.64 sigma. So the standard formula is LK is equal to LM plus 1.64. This itself is 95%, and remaining 5% in the graph is neglected. This is a 5% that is neglected. Next topic is partial safety factor or factor of safety. In simple words, it is nothing but it is also called as safety factor. That is one point. It is just defined as a ratio of design load to the working load. The factor of safety is very much required in order to make the structure much more stronger. The factor of safety for concrete is 1.5 and for steel is 1.15. These things are general things, but if we want to know more about this factor of safety, means first of all, these factor will be considered for the loads or materials, and it is also for different load characteristics. If we are designing any structural element, we need to take some partial safety factor for the working load. We should take partial safety factor for working load, because in limit state design we are not designing or considering the working load for the design. We are considering a design load. That means whatever working load we have, more than that we are considering the design load. So try to understand the difference. Whatever we have, it is a working load. Whatever we are going to consider by taking factor of safety, if we can design the load, that is called as a design load. So how much how much more factor of safety times the working load we are considering for the design is important, and that is taken from the clause 36.4.2 page 68 IS 456. So this table, whatever table we have, limit state table and partial safety factor for different materials like concrete, steel, with respect to collapse, deflection, cracking, or for concrete, like that we have taken a table. This table is important. Under that, the main thing is for concrete the factor of safety is 1.5 and for steel it is 1.15. So always keep these two values in mind. Usually anywhere they will ask what is the factor of safety for concrete, you should you should remember this value as 1.5. For steel it is 1.15. And the formula is partial safety factor is design load by working load, and design strength is given by characteristic strength by partial safety factor, and design load is equal to sigma f into, sorry, gamma f into characteristic load. This is about the factor of safety. Next is about modular ratio. First of all, this modular ratio is simple. It is nothing but ratio of modulus of elasticity of steel to the modulus of elasticity of concrete. Remember, always modular ratio should be denoted in a small m or has a small m is equal to ES by EC. That is modulus of elasticity of steel by modulus of elasticity of concrete. So this is a formula for modular ratio. Next topic is method of design. In RCC, design is to be designed for providing proper size of the structural element like footing, column, beam, slab and staircase, and to provide this proper reinforcement detail to the structural element, and to perform this we have various methods in RCC design. All the design should be followed by the guidelines only. Under that we have three different types of the method, that is working stress method, limit state method and ultimate load method. In these three methods, working stress method and ultimate load method are the earlier and old tradition method. But now all the designs of structural element will follow the limit state method only. Even in RC design guideline, that is I'm talking about IS 456, also depends upon limit state method. Now let us learn how to use these method in the design. Under that, the first one is working stress method. This method is used for the design of reinforced concrete, steel and timber structures. In this method, the working load has been considered for the design of structural elements with larger factor of safety, and due to this larger factor of safety, the size of the elements will become oversized, and due to this it will be uneconomical. This method cannot it cannot be what to say, it does not account for loads acting simultaneously. These are all some disadvantages of working stress method. To overcome this problem, new method have been invented, that is nothing but ultimate limit method. As I said, we are not using that ultimate limit method. So the next method will be limit state method. So before going to limit state method, generally I want to say about ultimate limit method. That is, this method was also called as factor method. Here the ultimate load is considered for the design, and for the design the factor load with the consideration. That is, a load factor, sorry if I said factor load, it's not a factor load, it's a load factor. The formula for this is load factor is equal to ultimate load by service load. This method will give the nominal size and the reinforcement, but to this it is economical. But due to this method will not take a proper care of the serviceability criteria. That is, in this method the cracking and deflection was more, both deflection and cracks were large. So due to this drawback, this method was not used, that is not carry forward. And to overcome this method, one more method was evolved, that is nothing but limit state method. So let us study about the limit state method. Here you can see, about the limit state method. This method is an advanced or advancement of the structural design philosophies. That is, I'm talking about working stress method, ultimate limit method. In this method, both safety and serviceability factors are considered. This method consists of two different types of limit state. That is, ultimate limit state, which consists of strength, overturning, and fatigue, sliding, and all. And the second one is serviceability limit state, which consists of crack width, deflections, and vibrations, and so on. In this method, we will consider the multiple factor of safety for the design. So this method will be taken care of both safety as well as serviceability. It will take care of both the things, that is safety and serviceability. Now in all the designs, limit state concept is followed and will be followed, but till now some special structures such as water tank, chimney designs will follow working state method. They are following this one. So sorry, not working state, it's a working stress method. So they are following this, but everywhere we are following a limit state method. After that, we have a difference between limit stress method and working stress method and limit state method. The differences are like this. This method is based on elastic theory, which assumes that concrete and steel are elastic, and the stress strain curve is a linear. But here it's not a linear, it's a stress strain curves is non-linear. In this method, the factor of safety are applied to the yield stress to get the permissible stresses. But here limit state in this method, partial safety factors are applied to get design value of the stresses. Here no factor of safety is used for the loads. Design load are obtained by multiplying the factor of safety of load to the working load. These are the three differences, but still we have three more. That is, exact margin of safety is not known. Here exact margin of safety is known. This method gives thicker sections, so less economical, it is more economical. This method assumes that the actual load, permissible stresses, and the factor of safeties are known, so it is called as a deterministic method. it is non-deterministic method. So these are the basic differences between these two. Hope you have understood. Thank you.